Hello students, how are you? Hope you are doing well. I am Vikas Monaker, PGD Physics from Kendriya Vidyalaya Lansdowne, and today we are going to study a few topics of chapter number 9, Ray Optics and Optical Instruments, and this is the lecture number 2. So we shall begin quickly. These are the topics that we will study in this lecture. First is refraction of light. Second is apparent depth of a liquid. Third is total internal reflection, and the fourth is relation between critical angle and the refractive index. So we'll start with the refraction of light. You have studied in 10th standard also. When light goes from one medium to another medium, its path changes because its speed is changing with respect to medium. In different medium its speed is different, so its path changes. This phenomena of change in path of light, that is called refraction of light. There you can see from the picture also, light is going from a medium which is relatively rarer to a denser medium, then it is bending towards the normal, and it is coming out from the denser medium to the rarer medium, it is going away from the normal. So its path is changing, and at both the faces refraction is taking place. So normals are drawn. This is the angle of incidence and this is the angle of refraction. For the second phase, this is the angle of incidence and this is the angle of refraction, which you can call angle of emergence also if you consider this as a glass slab. The laws of refractions. The first law is the incident ray and the normal and the reflected ray all lie in the same plane. They all meet in the same plane. And the second is there is a relation in between angle of incidence and angle of refraction, okay, with a particular parameter, okay, which will be defining the optical density of the medium. Okay, so the relation is given by Snell's law. So as Snell's law, the ratio of the sign of angle of incidence to the angle of refraction for a given pair of media is constant, and that is known as the refractive index. This constant mu is known as the refractive index of the medium. So mu equal to sin I upon sin R. Now we will study about the apparent depth of the liquid. The question might be coming in your mind, what is apparent depth? If you take a container and if you put a 5 rupee coin in the container, or in a glass, you can take a glass and you put a 5 rupee coin in a glass and you pour water into it, then the coin appear to be raised up. Okay, so in this way we can find that the real depth and the apparent depth, they are different. So we can make a connection in between real depth and apparent depth. So any observer, you can see from this picture, who is watching the object which is located at O, he finds the object at O dash. So the object appear to be slightly up. Okay, anyone who is observing from this side, he also watches or observe the object, okay, which is appear to be slightly up. So we can obtain a connection in between them, that the refractive index, okay, is equal to the ratio of real depth to apparent depth. If you divide real depth by apparent depth, you will get the refractive index of those two relative mediums. And the height by which the object appear to be raised up, that is known as apparent shift, or you call it normal shift. So normal shift, that can be written like this: HR minus HA, that means real height minus real depth minus apparent depth, and you can substitute the value and you can get this formula. So this is the formula for normal shift. Now what do you see here? This is a diamond and diamond sparkles. Why the diamond sparkles? That we are going to study. The diamond sparkles due to total internal reflection. Total internal reflection is the phenomena the complete reflection of light back into the same medium for the angle which is greater than a particular angle, which is known as critical angle. Generally, what happens when the light goes from a denser medium to rarer medium? You can see from the picture, the light goes from denser medium to rarer medium. Here the denser is considered as glass and the rarer is considered as air. When the light is going straight, it is going straight, okay, because the angle of incidence is 0, so the angle of refraction is also 0, okay. But when you increase the angle of incidence from 0, it bends, and as it is going from denser medium to rarer medium, it bends away from the normal. If we increase the angle of incidence, then the angle of reflection also increases. As you can see in the third one, here if we increase the angle of incidence, the angle of refraction here also increases. If we keep on doing this, particular stage comes, then for that the angle of refraction comes 90 degree. So for that angle of refraction 90 degree in the rarer medium, for which the angle of incidence in the denser medium is assumed to be I, then I be the critical angle. So critical angle is the angle of incidence for which the angle of refraction in the rarer medium is 90 degree. And if we further increase the angle of incidence, then instead of going into the second medium, light totally comes back in the same medium, okay. So this phenomena is known as total internal reflection. So the conditions for total internal reflections will be like this. The light should go from denser medium to rarer medium. It is essential that the light should go from denser medium to rarer medium. And the second thing is that the angle of incidence should be greater than critical angle. So light should be traveling from denser to rarer medium, and the angle of incidence must be greater than critical angle. What is the definition of critical angle? The critical angle is the angle of incidence in that denser medium for which the angle of refraction is 90 degree. In which medium? In the rarer medium. So this is the definition of critical angle. Now, relation between critical angle and refractive index. We can relate critical angle with the refractive index. Okay, as I have told you the definition of critical angle is that angle of incidence for in the denser medium for which the angle of refraction in the rarer medium is 90 degree. So if we apply Snell's law, the refractive index of air with respect to glass, because the light ray was going from glass to air, so that is sin I upon sin r. Instead of I, we put critical angle, and for the critical angle the angle of refraction is 90 degree. So we get G mu A equal to sin IC, but it is the refractive index of air with respect to glass. If we take the reciprocal, okay, that will be more appropriate, the refractive index of glass with respect to air, then we get A mu G equal to 1 upon sin IC. So we can say that refractive index is the reciprocal of sine of critical angle, I must say, okay, or sine of critical angle is the reciprocal of refractive index of denser medium with respect to rarer medium. Now the applications of total internal reflections, they are commonly used. Number one, mirage. Okay, you might have seen on the hot day on the road, it is appearing like a shimmering pond. Okay, water is moving on the road, so that illusion is called mirage. Second is totally reflecting prism, which is reflecting light totally. Third is optical fiber, which is commonly used nowadays. It is used in communication. Okay, next, as I have told you at the beginning, sparkling of diamond. Diamond sparkles because of this total internal reflection. Okay, so these are the things that we have studied in this lecture. Okay, thank you.